Hello, everyone. Thank you for joining us for today's session using GPT models in Python. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. The session is being recorded. It will be available to view on demand within 24 to 48 hours right here on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to Pamela. Thanks so much for joining us today.
Hello, everyone. It's great to see all of you in the chat and see people tuning in from all over. So today I'm going to be talking about using GPT vision models and specifically how we can use them from Python. I'm not doing any slides today, but I am going to be showing a lot of code and demos, and we will link to all of that in the chat so that you can try it yourself and follow along with everything we show. So first off, let's talk about vision models. What even are the vision models that we can use? So originally the vision model, the first one we had out was GPT Turbo Vision. These days we usually use GPT 4.0 or GPT 4.0 Mini. This is the Omni series that was announced by OpenAI, a few months ago. And it's what most folks are using these days in order to, to be able to ask questions about images. So here, this is the Azure OpenAI playground for a GPT 4.0 deployment that I have. There's also the OpenAI playground. So I'm actually going to show the OpenAI playground because this is something that probably more people have access to. So here you can see also that their tip picker, you can see, the models here, and it says, GPT 4.0, GPT 4.0 Mini. Both of these can handle getting image inputs. So these are, the models we're going to focus on today, and I'm pretty much going to use GPT 4.0 for everything. So let's see. So here we can try uploading an image, right? So I'm going to upload this cute image here and say, what programming language is this sticker for? And see if it can figure it out. So here I'm sending both text and an image to the model. So this is why we say it's a vision model or a multimodal model, because it can handle answering questions and doing inference on both text and images. So here you can see, okay, it's sticker features, blah, blah, blah. Imagery is associated with the Python programming language, and it's a reference to the 3.13 is a reference to the Python language. So these models are very good at understanding, understanding things that we throw at it. Let's try another one. I'll just pick something random here. Just describe the flow of this diagram. All right. So here I've uploaded a diagram that shows the flow of a Retrieval-Augmented Generation service. And here you can see it is able to describe it step by step. And and it understands everything. So that's how we can play around with it in the playground. And as I was saying, we can use it via openai.com. We can use these models via Azure OpenAI. And in that case, we just need to make deployments for what we want. So here you can see in Azure OpenAI, I have a GPT 4.0 deployment. If I wanted to, I could also make, a GPT 4.0 mini deployment if I wanted to use the mini version instead. And also, we can use it via GitHub Marketplace models. I don't know if you all have seen this yet, but basically GitHub is giving limited access to models. So you can't run like thousands and thousands of queries on these models every day, but it's enough so that you can start experimenting with models. So if you haven't joined the waitlist for this yet, join the waitlist. I know they're letting in more and more people every day. So we can put the link in the chat so that you can join the waitlist. And of course, if you already are in, then you can start using these models. And here you can see that it is a bunch of models. And these are also models that we have, available on Azure. The difference here is that all you need is, your GitHub account to get started with them. So we've got a bunch, from other providers like Cohere and Meta and Mistral. And then we've got the OpenAI 4.0 series. And then we also have embedding, and then we've got 5.3. So lots of models there. But if you wanted to do vision, these are the ones that you could get started with. A final option is to use Ollama. I've talked about Ollama in previous streams. Ollama is a way that you can run small language models locally. And you can see I've got it running on my machine. There's a tiny little llama up there. And they have added support for vision models. So the models they support are the Lava models. And those come from the research community. They've got examples here where you can describe the image. So that is another way that you could potentially interact with vision models locally. Now, I haven't quite got this working yet with my demo, so I'm not going to be using Ollama today, but I do encourage you to try it out for vision and see how that works for you. And hopefully we can get that working with these demos as well that I'm going to show today. So we've got 4 ways of using vision models: Azure OpenAI, OpenAI.com, GitHub Marketplace models, and Ollama vision models. All right, so now let's actually get into some code. So this is the first demo that I'll be going through, and actually there's multiple demos in this repo. So if you want to try this out, you can check the code out locally, or you can open it in GitHub Codespaces. So I'm going to be using it inside GitHub Codespaces. So either way, and you can configure it to work with Azure OpenAI or GitHub models. Either of those two. So Azure OpenAI or GitHub models. So here we go. I've got it open. So I'll show you my .env. And we put this link in the chat. So if you want to follow along, you can click on that link and you can open it locally or open it in Codespaces. So here is the .env, and this is, describing what I'm going to be using for my model. So I'm going to be using GitHub. So this is going to be using those marketplace models that we talked about. And I'm going to be using the GPT 4.0. I could also use Mini. We could try that out if we want to. And then I just have the endpoint here. So this is where it's going to be sending its request to for GitHub. All right, so that's set up. And now what I'm going to do is go to the notebooks folder and open this chat_vision notebook. And this is just a notebook with a bunch of examples in it, just so we can, start seeing how we can use these models. So the first thing we're going to do is set up the OpenAI client. So this, we do need a few SDKs for, and I've already installed them, right? So we're using the Azure Identity SDK, and that's for authenticating to Azure OpenAI. We're using the OpenAI SDK, and that's just for interacting with, with these models. And then, we just look at that .env and we figure out, okay, are we using GitHub or are we using Azure? And are we using Azure with a key? Are we going to use Azure keyless? So there's a lot of options here, but I can just run the cell, and here it says we are using a GitHub hosted model. Okay. So now let's actually see how it works to send a request with an image. So this is how we do a chat completion request, right? And let me just comment out, right, turn this into a more standard request, right? So normally when we send requests to these language models, we typically send, when these are chat models, we send what looks like a conversation. So we'll send a bunch of messages. We might start off with a system message, right? So we can add a system message here. So it'd be like role system, and then, content, you use lots of emojis and are talking to a 5-year-old, right? So there's our system message. And then we have the user messages, and, we can have a lot of user messages, but the final user message is the most recent one we want it to answer, right? And so here we could just ask, just a text-based question. We can say, oh, what is a unicorn, right? And then we send that to the model with all our messages, and we set a temperature for how creative we want it to be and get back a response, right? So here, this is just our standard chat completion, right? So a unicorn is a magical horse with a special twist. Great response. Okay, so now let's turn this into a vision request. So what I'm going to do is just I add on this image URL to the content of the message, and we can actually add on multiple image URLs. So we'll start off with one. So this is an image URL, and here the URL is actually pointing to a publicly available URL. So this is one option, is to point at a publicly available URL. So this is one, I got from Wikipedia that's public domain. And it was actually, I found it on the unicorn Wikipedia page. It's not a unicorn, but we can go ahead and ask, is this a unicorn? Also, are unicorns real? All right, so now we're sending this to the to the model. I see why you might think that this picture shows a type of animal called an aurochs. They have 2 horns, while unicorns are magical creatures that just have one horn. Unicorns are not real animals, right? I'm just curious right now what happens if you ask if Santa is real, just because I'm wondering if 5-year-olds can actually use language models or if they'll get their hearts broken. Actually, I already told our 5-year-old that Santa isn't real because apparently I can't lie. Yeah, apparently it won't lie either. That's good. All right. Anyway, so here we go. We've sent a request and we had, we had an image in it. So this is one way that we can send images. And that will work if your images are publicly available URLs. But there's lots of times we want to ask questions about images that aren't publicly available. And we definitely don't want to be like putting images on public available endpoints if they have private data in them, right? Because that would be a security issue. So much of the time, we're actually going to be sending base 64 encoded, data URIs that have our image information. So, in this case, I have this code here, which opens an image as base 64, right? So I pass the file name to it. I read in the file. I convert the data into base 64, and then I return back a data URI. So this is low convenient function. The funny thing is that I'm doing this with a JPEG, and I replied back with image/PNG, but it seems to just figure it out. So that's good. I should probably, vary this here based on the actual extension of the file name. But it'll work. This will work. So in this case, the URL that we're sending is actually a data URI. So let me just show you what that looks like. Open image as base 64, your .jpg. All right, so this opens it locally and then turns it into a base 64 encoded URI, which is this really, really long thing. So it's not the most efficient use of, bandwidth, right? We're going to send this really, really long string over, over the wire. But it, that's, one of the drawbacks of how, having to send images this way. But it'll work. So let's go ahead and send that. All right, and so this time I've asked it how could I make this into a unicorn? All right, so it says transform the animal image and calls some creative steps, remove or edit the horns, add a unicorn horn, enhance the mane and tail. Okay, lots of good instructions there. So what you can see is that in both cases, it totally understood what the image was and was able to answer the question. So basically, like, totally use this if you do have a public URL for your image and it's, publicly available data and there's no privacy issue. But if you are dealing with private images, you want to use this approach instead. So so let's look at some examples of this to get an idea for what different ways we might use this, right? And these are actually examples. I asked my colleagues, like, what are your favorite ways of using vision models? And so these are examples from my colleagues. So one example here is to help with insurance claim processing, right? So we have this picture here, dented car, okay? And so we say, you are an AI system that helps auto insurance companies process claims. You accept images of damaged cars and can make judgments about the validity of the claims. So in this case, we say the claim states that this damage is due to hail. All right, so once again, this is the picture. And we're saying the claim says this is due to hail. Is this a valid claim? So we're basically trying to ask it, does it look like this damage was caused by hail? Now, a human looking at this would probably say no, because that would be a really, really big hailstone. But let's go ahead and send it to the model and see what the model thinks. It says it is not consistent with hail damage. Hail damage, presents as small round dents. This one's more significant. So it does not seem valid. So this seemed to work pretty well. And so this could be an approach that could help with, increasing the efficiency of going through insurance claims. Now, I always want to warn, if you're going to be using any sort of machine learning model, whether it's one of these large language models or if it's a custom model, if you are making decisions that affect people's lives based on the outputs, then you should have a human check, or have a way for someone to counter the claim and say, no, wait, actually it was a really big hailstone or something, right? But it does do a really, really good job of this, right? And then we have this example here, which is, getting help on appliances, right? So here's a dishwasher that has like a crazy UI, right? So imagine you're a guest at a home, like an Airbnb, and you see this dishwasher and you're trying to understand, how the heck do I use this? And apparently multiple of my colleagues own this dishwasher, and it's very unobvious how to use this. All right, so we're just going to say like, oh, how do I set this to wash the dishes quickly? And we'll see if it's able to help. So let's see, we have all these things here. Really, so I always make my partner start our dishwasher because I just can't deal with these sort of interfaces. All right, so it says you should turn on off and then do the quick 45. So maybe that's right. So they can go ahead and try that out. All right. Other good use cases are using vision models for accessibility, right? So, lots of people have vision impairment where they're fully blind or just have a hard time seeing. So we can use vision models to, help read off things for them, help answer questions about visual things in the world. So one example is menus, right? So, look at this menu, which is using crazy fonts, and it's actually even hard for like a human to read these fonts because it's a little too cursive. And, maybe a vegan is going out to eat and wants to know, is there anything good for vegans to eat here? Right? So we're hoping that it's going to be able to read all this text and then also answer the question, right? So you can use vision models with images that have text in them. And in fact, they work pretty well for that. I don't know exactly how they're, how they're implemented behind the scenes. And I don't think it's been published yet. There's been some good blog posts trying to figure out exactly how that's implemented. But they do a really good job at reading text. So it says it doesn't explicitly label dishes as vegan, but here's some things you could try. Try this and then ask the waiter about this, ask the waiter about that, and verify the restaurant. So that works pretty well. So that's a good use case for vision impaired. Another great use case is creating alt text for images. Many of us create websites that have lots of images, and we should be having alt text on those images so that somebody visiting the web page can understand the image without being able to use eyes, right? But many people don't have alt text on their images, right? And you might have a website that has like hundreds of images that don't yet have alt text. So you could potentially use an LLM to go through all your images that don't have alt text yet, have it suggest the alt text, go through and check that they look good, and then put it out there, right? So here we're doing the architecture diagram, right? So here's the architecture diagram, and I asked it to suggest an alt text for the image, and this is a pretty good alt text. It's probably a little verbose for alt text. I might remove some of it for an alt text, but that's something you could affect in the system message and say like, oh, your suggestions should be no greater than 5 sentences or whatever. You could do few shot examples. But I do really think this is a really promising use case is to be able to make our websites more accessible. And then table analysis. This was a favorite use case of my colleagues as well, right? So here I have a table from my local plant nursery because I want to buy some plants soon. I'm going to ask it, how do I zoom out? There we go. All right. So it's not even very, it's not very high quality, but let's see what, if it can tell me what is the cheapest plant, if I just want to like fill in with a cheap plant. And it says the cheapest plant is the thin grass at 0.58 per stub. So if we take a look, we can see 0.58, and that is indeed the cheapest plant. So it's pretty impressive because this is actually a pretty aliased image. If you look here, right, it's not very high quality. So with this low quality image, it was able to read everything, read the table, see like the rows of data, right? So it figured out, okay, this is the cheapest, column for price, and then looked and see like, okay, it's a thin grass, get this stuff in the row. So it's able to do both, like look at tables as having both rows and columns. So that's really cool. Okay. All right. So those are some really interesting use cases. I see some good conversations going on in the chat, and we are going to be talking about RAG with vision later. So I think we're going to hit up your question later about that. I see a good comment about from Adam Pfister. Combine this with structured output, and that's a pretty powerful workflow. So that's a great point, right? So that you could use structured output or function calling, either of those, combined with sending a vision request, right? And so this is a way that you could, that you can get, as I said, more structured output from your response. So if you wanted to do like entity extraction or, it's like identify things in this, and you had specific outputs that you needed, right, for like a workflow, then this could work really well. So you could do structured outputs, you could do function calling, you could do JSON mode. Those are all different ways of getting structured output from the API. Structured outputs was just introduced, and the reason that it's exciting is that it guarantees that it matches the schema. With the other previous ways of doing it, you sometimes got results that didn't match the JSON schema, but in this case, they're saying it's guaranteed to match the schema. 100%. So great point. All right. So those are some cool examples. Now let's actually see how would we build a chat with vision app. So I have a in this repo, and actually the whole point of this repo is actually the app. So there is a Python web app, and I'll just go ahead and start up that app here. So let me open it in the browser. All right. So here is my chat, right? So we can just say, we can say hi to the LM, be polite, okay? And now we can upload an image, right? So we'll say like, is there any fish on the menu? Let's see. So there's the image, and we're asking the assistant if there's any fish. It says yes. There's antipasti, and there's pasta and risotto. And we get some options here. So this is an example of how we could make a chat application that can talk on an image. So how did we actually build this? So it has a front end and it has a back end. I guess let's look at the front end first, right? Since that's where we do the uploading. So if we look at the front end, what we can see here, right, is I've got basically, some file upload code. And when I get a file, okay, so here, if there is file, then I'm going to convert it to base 64. So in this example, I decided to do the conversion to base 64 in the front end. This isn't the only way of doing it. We'll see another way soon. But in this example, when I get the file upload, I immediately converted it to base 64. And this is how I converted it to base 64. I use this file reader and then read as data URL. And that comes back as a base 64 data URI. And so then I have a base 64 data URI. And then I just send that to the backend. So this is basically going to end up looking like what we need to send to the model eventually. So that's one way of doing it. And in this case, I am doing a streaming UI. You might have noticed that the results were streaming. Let me ask another question, like gluten-free. All right, here's some gluten. So notice that it's streaming. So that means as we get tokens, we're displaying the tokens. So I'm doing streaming, and that's via this chat protocol SDK that I'm using. Let me do the ACA for that. Let's see, AI chat. So aka.ms/AI chat will bring you to this package that I'm using for streaming. So if you are building a front end and you're trying to stream from a back end, then this is what I recommend using, because it'll take care of streaming in the chunks to the front end using a pretty nice way of doing that. And there's also lots of samples here too. So the samples here, we've got samples in C#, JavaScript, and Python. So if you're working in languages other than Python, we've got more examples here. And these all now have examples of how to handle files. We just added this yesterday. So if you want a front end that can handle both text and files, you can use the chat protocol SDK and use those sample backends. And then there's a sample front end in React. So that's what I'm using to do the streaming. All right. So, and then I get back the response. Okay. So that's the front end. Basically, we're doing that base64 in the front end for this example. And then in the back end, here is my chat stream handler, right? So I get the JSON. So I guess it comes in as a JSON. I get the messages and get the image out from there. And then I construct that user content. So I'm basically just constructing what we saw in the notebooks, right? So here we've got the text, which is the actual user question. We've got the image URL, which is that base64 image. And we also have all the previous messages in the conversation, so we can send those as well. And I send those to the model. And in this case, I am streaming. So what I get back is a generator with the responses, and I can send them back to the front end as new line delimited JSON. So that's what this does here, is it sends back a streaming response. Let me go ahead and actually open up. Let's see if I can open up my browser tools so I can show you what it looks like. All right, let's see. What's this? Okay. All right, so here I'm sending that sticker, and you can see here is what I sent, right? So I'm sending that base64 URI, and I'm sending all the previous conversation, right? And then what I get back, it's a stream back from the server. Okay. All right, so that is how our front end and back end works. And we can also deploy this to a server. So I do have this deployed on Azure Container Apps. And so that's all set up with Bicep. So Bicep is infrastructure as code. So if you do want to deploy it to Azure servers, you can start from this demo and just run AZD up, and it'll deploy for you. And you can see that it makes the GPT-4o deployment. And one thing I want to point out is that it is using this global standard SKU. This is a new SKU. So instead of picking a particular region for your OpenAI deployment, it'll use this global deployment, and that means that it might pick from multiple regions. But this can work a lot better for capacity, or we're able to kind of do more load balancing behind the scenes. So this is something you can use with those new GPT-4o models. All right, so let me see the most recent questions here. Okay, some questions about RAG. And let's see. So we have this question. Is it possible to ask the vision model to infer the schema for structured output if I'd like to convert the image of a table into JSON, but I don't know how the table looks? That's a good question. We could just try that and say, let's see, output JSON that describes this table. Use the columns as JSON keys. I actually have never done structured output with, I'll just try it without doing structured output. I haven't done structured output with Vision myself. It sounds like some other folks in the chat have, so maybe they can give their experience here. But generally, you know, these large language models are pretty good at JSON. So I kind of think it's going to work without, but this here, I'm not even specifying structured output, but here, yeah. So look at this. So species, common name, quantity, size, price, right? So in this case, you know, my image had, if you look at my image, it's kind of multiple tables. So it decided to do like a nested JSON dictionary, right? Because I didn't tell it how to deal with the fact that there's, you know, divisions in the table. You know, so depending on what you're doing, you know, you might want to give it more explanation, and you probably want to actually use JSON mode or structured output mode, because this is just a string of JSON basically. This is just like a markdown. But as you can see, like, it's pretty good at being able to turn this into JSON. Like it got those column names exactly correct. All right. Yeah. So if anyone in the chat can give some more specific examples that you've done, that would be great to help them out. Okay. So there you see. So you can deploy it. Now let's talk about RAG, because I am hearing lots of questions about RAG. So yeah, we can do RAG with these vision models, meaning that, okay, so first let's say, what is RAG? RAG is a technique where we can ask an LLM questions based off some context that we send to that. And the context usually comes from some sort of search engine or database. Now, the one I'm going to show here is using Azure AI Search as a knowledge base. This is a RAG solution I show a lot because it's a very popular RAG sample, and it's very fully featured, and it does include vision as an optional feature that you can add. So you can go to aka.ms/ragchat just to learn about this demo. And then if you want to enable the vision feature, you can go to ragchat/vision. So we can put these two URLs in the chat. So we got ragchat or ragchat/vision. And this just shows you how you can enable this optional vision feature for the app. So I'll go ahead and show how it works, right? So actually let me just show the non-vision, right? So I'm going to uncheck that option, right? And so we'll just ask a question here. And so what this is doing is that it's searching an AI search index, and this AI search index has all this text that's been extracted from PDFs. So it's trying to answer these questions based on the text that comes from PDFs, right? And we can look at, you know, these are, you know, the supporting content. This is the context that we sent to the LLM. We could open the citation up and actually see the PDF. Is it gonna load? I didn't test that part this morning. Sometimes it's a little slow because it's doing all these checks. But basically it's coming from a PDF, right? So we say, okay, what does a product manager do? We get back these results from the search engine, and then we send those results and the question to the LLM, and we get back an answer. Now, the standard way of doing RAG is that we want to do a really good search of our search engine. So we do what's called a hybrid search. A hybrid search does both a vector search and a full text search. So what you'll see is that, you know, we've got text content that we're searching, and then we also have embeddings that we're searching, right? So that's what it means when we're doing a hybrid search, is that we're searching the text and we're doing a vector search in the embeddings, and then Azure AI Search is merging those results together and then using the semantic re-ranker in order to come up with the best results. And so that's all, you know, configured here, right? We're using semantic ranker, we're doing a hybrid search, and that all works. So let's go ahead and try this with vision and ask a question here. And so here, this is, once again, it's searching AI search to find answers for this question. The difference here is that it is searching two embedding fields. So if we look at this, it is searching both the embedding field and the image embedding field. So what we've done is that for all of the PDFs that we've indexed, we've extracted the text and we've turned that into a vector, but we've also turned each of the PDFs into an image. And we just do that page by page right now. So we turn that page into an image, and then we make an embedding of that image. So then when we're doing this search, when we're doing vision, we're actually searching both. We're doing a vector search on both those fields. So this is like a multi-vector search. We're able to, merge those results. So this is one way of handling it. There's another way you could do this, and I think this was maybe mentioned in the chat, which is we don't have to do the, we don't necessarily have to have the image embedding. What we could alternatively have done is maybe asked an LLM to describe anything that was non-text in an image, and then just added that, had that as part of our embedding. So there's definitely multiple approaches to this, and there's some benefits of this approach. There's also some drawbacks. So it's going to depend on what it exactly you're indexing it, right? Like, are you indexing lots of photos? Are you indexing lots of diagrams? Are you indexing lots of things that are a mix of PDF and images? Depending on what you're doing, there's a ton of different approaches. But this is certainly an approach you can start off with that can get you really far. So we search on both the image embedding and the embedding, and so we get back the results that are optimal for this query, right? And then we send those. And now when we send these to the request, we're sending both text and we're sending the images. So you see this request down here, it includes both text and images, or we can just look at it this way, right? So when we send the request to the LM, we send it all the matching text and we send it all the matching images, right? And so it can, if something wasn't in the text, it can look at the images. It just looks at whatever it needs to look at in order to answer the questions. And here you can see like this question was about something that was only in the graph, and it was able to figure it out based off of this graph here, the -6, right? So it found that answer here. So this is one approach for doing this. Now, if you're going to do this, you do need to be able to convert your PDFs or whatever kind of document you have into PNGs. So I did make an example of that in that chat repo, right? So and this is basically what we do in the other repo, right? So let me go ahead and connect to OpenAI. Okay, all right. And here I'm going to use some libraries here. So we have Pillow, which is an image library for Python. And then we have some PDF parsing libraries as well. And these are what we use in the Azure Search OpenAI demo, right? So we're going to bring these in. And what I'm going to do is open up this PDF. So I have this plants.pdf, which I downloaded from my local nursery. And I'm opening it up and checking how many pages there are. And then using PyMu PDF in order to open it. And there I can load each page in the PDF, and I can turn each page into a pixel map, and then turn that into an image and save that into a PNG. And so once we have, the page of an image as a PNG, we can do stuff with that, right? We can store that in blob storage. We can create a vector embedding of it. We can send that, that PNG to the vision model. So here, let's go ahead and send these to the vision model. So here, I'm actually going to send all of the pages. Actually, that'll be pretty slow. So I might do just the first 3 pages. That's not correct. Range 3. There we go. So I'm going to send the first 3 pages. So it's saying you can send multiple images at the same time to the LLM. So that's what I'm going to send here. And I've asked it what plants are listed on these pages. So here it's going to receive the, the PNGs for all these and then answer that question. All right, let's see. Yeah, okay. You see, I see some good questions, so we'll tackle those after we get a response here. Now, obviously, this is taking a lot more time because I'm sending 3 pages. Originally, I was going to send 14, but decided to speed it up. So here we go. It's a detailed list, and it is very, very comprehensive. And it overflowed my my notebook here. So this is probably everything that is across those 3 pages. So that's a cool thing. It can read a lot. And it can answer a lot of questions. So this is basically what we're doing here, is that we're sending multiple images and multiple bits of text and asking to ask questions based off all of those things together. All right, so I see some good questions. All right, so the first one, there's a front-end chat with your data that comes as a sample application on Azure. Is that code available? Great question. So you can actually see that if you go to the playground, you'll see this with the there's like a little button that says add your own data, right? This one, add your data. So if you use this, you can actually, it'll give you a whole web app that you can deploy to app service. So if you are using this and you want to dig into its code more, then go to this URL here. I'll give it to Anna to put in the chat, right? So this is the URL that corresponds to add your own data in the studio. So if you wanted to dig further into this code, you could do that. We actually have a comparison between Azure Search OpenAI demo and the sample app, this repo. Here's the comparison. I'll also stick that, see if we can stick that in the chat too. And so this can just be helpful because a lot of people are trying to figure out what repo to get started with. The real big difference is that when you're using this sample app on your data, it is doing RAG via this data sources parameter to the chat completion API. So I didn't show that at all, but it would look something like data sources, something like this. And then we would specify, an AI search index or a pinecone or something like that there. So that if that works for you, that's great. The advantage of using Azure Search or OpenAI demo is that all the RAG code is actually inside the repo itself. So if you find that you need to customize something, then you can dig into the code and you can customize the RAG flow yourself. So it just depends on how much customization that you need of the RAG flow itself. I also don't know that app has vision. Maybe it does now, and maybe I need to update this. Last time I updated this comparison, it didn't have a vision approach, but it may have a vision approach now. So I'll just have to check on that. But yeah, we have multiple ways that you can get started. Hopefully you can find a way that works for you. All right. I see a question, and issues connecting my AI model to a custom UI and encountering issues. So generally, if you are encountering issues, the best thing to do is file an issue on the issue tracker, right? We try to get to them, within a few days. So I would say, file an issue and we can help you through it. Even if the issue isn't with our code, just think of this as a discussion forum about the repo, right? So feel free to file an issue and we can try and help you through it. I will say that right now there's actually an issue with Azure OpenAI. So I actually, for all the demos I showed you today, I'm using either GitHub Models or OpenAI.com because there is a current issue with Azure OpenAI with the vision. It might be resolved at this point. I don't know. We can check to see if it's working. If it's working now, test. Yeah, if you were using Azure OpenAI like during this stream, you may have had issues. Hopefully it's fixed now because at least this one just went through, so that's good. But yeah, generally file an issue if you're having any problems. All right, I see a question. So from Dhananjay, we can do BM25 plus text embeddings plus image embedding search. Right. So that's basically what this is doing here. When we're doing a hybrid search, right? We're doing hybrid search here, and we're telling it which vector fields to do. So we have all of this as like options that you can play around with, right? So we're saying do a hybrid search and search both the text and the image embeddings. And so that'll do a multi-vector search, and then it'll also do a hybrid search, and we're using semantic ranker for retrieval. So this is the most powerful way of searching generally. If you want to read more about the best ways to search with Azure AI search, check out this blog post, which compares hybrid search to hybrid plus semantic ranker, hybrid vector keyword, right? And what we're adding here is that we're actually searching multiple vector fields at the same time. But yeah, this is a really powerful combination. That keyword search is BM25, which is what the comment referred to. The vector search is using HNSW, which is the most popular vector indexing strategy right now. Hybrid uses an algorithm called reciprocal rank fusion. And then the semantic ranker is this re-ranking model that's used by Bing as well, that looks at the user question, looks at the results, and then re-ranks the results according to the user question. So you really want the whole stack to have the best results when you're using Azure AI search or any sort of search engine. All right. Okay, and Farzad, who's from the AI search team, is saying, as a bonus step, could we use GPT-4o to create an image summary? So yeah, for sure. Yeah, you could create an image summary with GPT-4o. So the other thing, there's a lot of ways that we could go about doing RAG with visions, and just generally a lot of ways that we can use these image models, right? Because in this case, we decided that we'd like convert the PDFs to images and store those image embeddings, and then send like each image page. But I was saying, like, we could also have used GPT-4o in order to write very, very thorough descriptions of an image, and then store that instead of storing the image embedding, or in combination. So I will say one issue that I have seen with this approach is that you can accidentally have really noisy embeddings. And this is a general issue. Anytime you're using vector search, you have to be really careful about noisy embeddings. You basically want to make sure that when you create a vector embedding of something, it should have some sort of high signal, right? It should actually embed something valuable, some valuable content, right? So for example, if you create a vector embedding of like an empty string, that's a really bad vector embedding to have in your vector index. It's going to end up like matching everything. So you don't want to create vector embeddings that accidentally overmatch too many things. Like, you want all the vector embeddings to be, actually embedding some significant content signal, right? And I've seen this happen in particularly with image embeddings. So for example, there's a customer that had like a bunch of like 1950s manuals, and they added all of it to the index, including the front cover, the back cover, the in-between pages. And some of those were basically blank, right? The back cover had like an insignia on it, like a logo on it, right? And so when they embedded that back cover, which was just a big blue page with a logo on it, that back cover ended up matching highly for so many queries. Just because of the way vector search work and vector embeddings works, like that particular vector was very close to a lot of things in the search space, and it was really, really throwing off the queries. So one thought we had for them was, maybe what would be a good thing is that in the step where you're doing the indexing, you could decide to only index the to ask an LLM, like, hey, is there actually something, a diagram or a photo or something in this that should be saved as an image? If so, do it. Basically, like using the LLM to figure out, is there something significant visually in this that should be indexed visually, right? That would be one approach, is ask to figure, using the GPT-4o in order to decide, is this image worth indexing? We had other ideas as well, like writing captions of the images and not even doing the image embedding. So that is definitely a gotcha that I've seen people run into, and something to consider when you are indexing things, especially when you start indexing images, is just make sure everything you're indexing is actually meaningful. All right, let's see. Okay, so all right, so I think let me see if there were earlier questions that I think we've answered a lot of the questions. If there's any other questions, feel free to put them in the chat. So I basically shown the demos that I wanted to show. One thing I want to plug right now is that we are going to have a hackathon all about RAG, and I see there's a ton of interest in RAG in the chat, so that's great. So I think you're going to love our hackathon. So just go to aka.ms/raghack and you can learn more, and you can register. So you can register on this link here. And as part of this hackathon, we are going to have so many streams. All right. So we've got streams for like every language, every retriever, every approach, every framework. Like we're trying to hit it all up. So we'll have, RAG with C#, Python, JavaScript, Java, with LangChain, with Llama Index, LangChain for J, LangChain JS. We'll talk about responsible AI. We'll talk about different retrievers. So Azure AI Search, as we just saw, but we'll also talk about Postgres, Azure SQL, Cosmos MongoDB. The MongoDB will be from John Aziz, who I think is in the chat. And then AI Search will actually be with Farzad, me and Farzad is also in the chat. We're going to have an intro to Graph RAG. We'll talk about internationalization, agentic RAG, building a code interpreter, using AI Studio, using AutoGen, adding data access control, using other models besides the GPT models, and then finally evaluations. Oh, and that's great. So I did see there was a question about evaluation, so we'll get to that. And we'll also have some Spanish ones, and I got one more Spanish one I'm going to add here. We'll have Portuguese and we'll have Chinese. So it is going to be just a RAG fest, 2 weeks, all these live streams. And of course, you can submit for prizes as well. And the prize is cash, $500. So I hope to see lots of you sign up for RAG Hack and come to the streams for that, because I'm really excited for being able to cover so many different ways of doing RAG, different approaches and different retrievers and all that, because what we've seen is that there's just a lot of interest in it, and it's a really compelling use of LLMs, one of the most compelling ones. So we really want to make sure that we, cover everything about it. So evaluation. There was a question about evaluation way back. I don't even know if I can find it, but I think the question was like, how do we evaluate when we're using, when we're doing vision? And, so I have not evaluated with vision yet. And, the reason I haven't is because, so typically with evaluation, right? So I do have an evaluator repo. It's this one. We'll stick that in the chat too. And this one, the first step we do is that we generate ground truth data, right? And in order to do this, we actually send stuff to an LLM. So right now, this generator that I have only understands text. So my first step would be that I need to extend this to understand images. If any of you want to do this, take this on, go for it. So it would need to understand images so that we could pass the images and have it, generate a bunch of potential question answer pairs, right? Because we need ground truth data so that we can test things that are working, right? You can also write your own ground truth data manually. That is a lot of work, but if you have the time, ability, resources to do that, that would be another approach, right? So first step, ground truth data. We can certainly use an LLM to generate that ground truth data, especially if it's, frontier level LLM like GPT-4o. But that's the first step, right? We need that ground truth data. And then the next step would be sending that stuff to an evaluation framework. So here I'm using like the Prompt Flow Evals SDK and asking it to evaluate and doing, different metrics, like groundedness and relevance, and stuff like that. And this also probably needs to understand images. So I haven't tested this with it yet either. So I think basically it's an open, open question. If any of you have actually done evaluations with RAG with vision or just with vision generally, let me know, put in the chat what framework you're using. Because I do think this is something we need to figure out, because generally whenever you're building something on top of an LLM, you need to evaluate it, right? Because as you've seen, like LLMs can be very creative. They can sometimes be too creative. They don't always adhere to, system prompts and instructions. And if we're, using this for user-facing applications, we need them to give high quality answers, right? So I do think we need to figure out evaluation. Maybe we can figure that out for vision in time for RagHack, or maybe some of you have figured that out already. But I'm really happy that you all are thinking about that, because it's a really important thing to do. Okay, a question from Miguel. Is there any video or book for learning more about using vision models for business use cases? Good question. Let's see. So I know Meet, generative AI book. I think it was a Meet who made this. Yeah, generative AI in action. This is from one of our colleagues. Let's see, pre-order, so it should be out soon. So I don't, I generate text and images. Yeah, so I don't know how much this it does talk about multimodality. So this is one book I've heard about, but I haven't dug into books. I mean, here's the thing: is like this stuff changes so frequently that I think it's somewhat hard for books to keep up. Yeah, so I think generally, like, I look at blog posts more, like LangChain. LangChain has good good blog where they'll talk about stuff. Like, this was a blog I was reading lately. They had case studies. Azure also does case studies, right? So that's a great question. If anybody has any other recommendations for reading about vision use cases for business, that would be really helpful to share. All right. Any other questions here? Just remember, just go ahead. If you're ever looking for anything I've shown, just go to my GitHub, github.com/Pamela Fox. And there you can find links to all my repos, right? So the ones we showed today was the vision and Azure search. So go ahead, get started with those, file any issues that you run into, and let us know, what other repos we need to make. As many of you know, I'm like an addict at making repos because I really like to provide all of you with like end-to-end solutions that can be like fully run locally and deployed and all that stuff. So we're trying to figure out like what are the use cases we're missing. Like, is there some big use case we're missing that that would really help to have a repo for, an app for, a notebook for, or whatever. Let us know, because then hopefully we can put something together that will help help all of us with the most common ways of using these models. I see a question from Dhananjay. Do I have any personal preference among LangChain, Llama Index, Haystack, and Semantic Hurdle for RAG? My answer is none of the above. I am not so into frameworks. I use the OpenAI SDK for everything, right? So I like to use that because it's the common denominator right now. As more models are coming out, we're waiting to see if that is going to be the common denominator going forward, right? Now, more models, a lot of them are coming out with OpenAI compatible endpoints, so it's still a common denominator. But right now, I like to use the most common denominator so that I code in that lower level, and then if you all want to port something to Llama Index or LangChain, you can. But I don't want to make anyone have to do that. So I tend to just do everything with the OpenAI SDK, right? So we can look at here's our the simpler vision approach here, where it's just going to do a search with the vectors, with those multiple fields, gets back the results, gets back the image URLs for them, and then send those to the OpenAI client, and then streams back the response, right? So this is just with the OpenAI SDK. And if all of you want to use a framework on top, then you could do that. I have colleagues that do like to use Llama Index, LangChain, Semantic Kernel. So, it's one of those things that's, I think, a developer preference. So I decided I'll be the colleague that does everything with the OpenAI SDK. And then I have other colleagues like Marlene. She does a lot with LangChain. So if you look at Marlene Mangami, if you look at her repos, you'll find a lot of LangChain ones. Generally, if you go to awesome AZD, azure.github.io, let me link this one. You can find some, examples from other people as well. So we should have, so we've got some LangChain in here. We're going to have an AI gallery soon as well. This one is not just AI. We'll have an AI gallery soon that'll make it really easy to find all these AI examples from myself and all my colleagues. That's a great question. That's always the hard thing, is what framework to use. And I just don't answer it by using nothing. All right, everyone, we are at time. Thank you for all the great questions and comments and answering each other's questions in the chat. I hope to see all of you at RagHack from September 3rd to 13th, where we're going to have a ton more streams and we can keep the conversation going. Bye, everyone.
Thanks, everyone, for joining. Thanks, Pamela, for another great session. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find the link on the screen or in the chat. Today's event code is 23294. We'll see you on the next one.